Hello, everyone, and welcome to the Data Umbrella webinar. I'm going to do a quick introduction, and then Sam is going to do her talk, and then we'll have Q&A at the end, but you can also put any questions you have in the chat at any time, and we'll get them answered whenever it's a good place for a pause. This webinar is being recorded, and I'm going to share the link to where you can subscribe to our YouTube in the chat. Data Umbrella is an inclusive community for underrepresented persons in data science, and we are volunteer run. About me, I'm a statistician, and you can find me at Reshama S on Twitter, LinkedIn, and GitHub. We do have a code of conduct. We ask you to just be professional and respectful in the chat, and thank you for helping make this a welcoming and friendly community for everyone. There are various ways that you can support a community. The first is to, first and foremost, is to follow our code of conduct. The second is you can ask any questions or join our Discord. The link to Discord is on our website. And we also have transcripts for all of our webinars that we are happy to have help with in editing. You can also donate to our Open Collective, and it is at opencollective.com/dataumbrella. We have all of our webinars on YouTube, and we have a bunch of playlists. One of them is contributing to open source, so check that out. We also have a playlist for career advice, which is quite popular, and we have 3 excellent speakers who have done great presentations on that. And this is just a small collection of some of the events that we've had. We also have a job board. Check it out, jobs.dataumbrella.org. And if your company is hiring, feel free to post on there as well. We also have a lot of resources on our website, particularly related to creating an inclusive and welcoming environment in terms of allyship, burnout, diversity, and responsibility. We are on all social media platforms as Data Umbrella. The place to find out about upcoming events is the Meetup, which is Data Umbrella. Our videos are on YouTube, and we are pretty active on Twitter and LinkedIn. So depending on your choice of platform, feel free to follow us on whatever you spend your time on mostly. So today's talk is going to be on Pandas using Jupyter Notebook. Sam is coming back. Sam is back for a 3rd time. We love her so much, so we're happy to have her back. Sam is a data professional in New York City with a passion for turning high-quality data into valuable insights. Sam has a PhD in computer science and has worked for several data-centric startups. You can find Sam on LinkedIn, Twitter, and GitHub at spdale. Our next event is Modern Time Series Analysis with StumpY. That is on August 10th, and that sign-up information is on our Meetup group, which I will share on the chat as well. And I'm going to hand it off to Sam now.
All right, thank you, Reshama. Let me share my screen, and I hope everyone can see this. So you should all be able to see my this GitHub page. Please do let me know if you can't see that. So I'm going to get started. Welcome everyone to this tutorial on data analysis with Pandas and Jupyter Notebook. I have already posted the link to this GitHub page in the Slack channel. In the chat. In terms of how we're going to run this workshop, I used to do this in person and actually had it hands-on, and people would follow along. Because I won't be able to help anyone directly with the specific issues they might run into, feel free to follow along with this using the notebook that I've provided, but I won't be able to answer specific questions if you run into issues. So another option for you is to really just watch this presentation and then just go through the notebook later on. I would probably recommend that rather than trying to follow along with multiple screens and everything. But just in case, so this is, like I said, this is the GitHub. The Reshama also just posted in the slides, and you have 2 options to run this notebook if you want. So one option is what's called a binder link. I'm going to actually explain that in a minute. Basically, you just click this button and it will start up a binder link, a binder for this notebook, which gives you a browser-based option for running the notebook that I'm using without having to install anything locally. So I really recommend that if you just want to play around with it. You can basically just hit click the binder, launch it, and then click this notebook, and then you will get to this notebook. The other option, I have some instructions to running the notebook locally to do the setup. So you can download everything. You can install all the requirements. You can run your notebook locally, so you can do all these things. There's instructions there. But like I said, I think for now, honestly, the best option for y'all is probably just to watch the presentation and then go hop over to the GitHub later on and go through the notebook by yourself. Okay. Great. So let's get started. I am actually, so first of all, actually just real quick to show you what Jupyter Notebook is. So basically Jupyter Notebook is a another Python library. It's a web UI. It's a web-based interactive development environment that helps you just run Python code, any kind of Python code, and it's based in a browser. So all you do is you install Jupyter using pip install. Like I said, I'm assuming for this workshop you're a little familiar with Python, and then in your terminal, so I can show this. You know, what you do is you run Jupyter Notebook. So if you run Jupyter Notebook, if you have Jupyter installed, you hit enter, it will start up a terminal shell that looks a little bit like this. So it will show you all the output here. And then you can just go to your local notebook. It will open up a page that looks like this. Again, like this is the binder hub. We've already seen this. And you can start opening the notebook. So your notebook file will be called IPyNB, IPyNotebook. Great. Okay, so I'm switching over actually to my local version right now, but this should be identical to what's in the binder hub. So let's assume I have run Jupyter Notebook. I have started up this web server, and I have clicked into my IPyNotebook. And now I'm here on this notebook. That's the workshop. One thing to mention is that for the purpose of this, I am going to actually just toggle the header. Sorry. So usually, as you can see here, you can see the title of the notebook. I'm just going to remove that just to give myself a little bit more space on the screen. Okay, that was the preamble. Now for the actual workshop. So what were we going to do today? So the goal of this workshop is really to just give you a tiny bit of an intro to data analysis with Python using Pandas and Jupyter. I'll go through the process of loading data, inspect data, clean data, and do a little bit of analysis, and even do a little bit of data visualization, which is really exciting. I'm really only going to scratch the surface of anything that's possible with Jupyter and with Pandas and the plotting libraries. There's a ton more stuff you could be doing. This is really just to give you a taste of it if you haven't had any experience with it. This is also very suitable for people, for example, who might be using R and are thinking of just exploring how to do similar things that they're used to doing in Pandas. Okay, so for the structure of the tutorial, I'm going to give you a little bit of intro and background, just like a recap on what all of the things are. What is Jupyter? What is Jupyter Hub? What is Binder? What is Pandas? What is matplotlib, seaborn, et cetera, et cetera. Then sort of also still as the intro, I'm going to do a very brief Jupyter exercise. I'm not going to spend too much time on Jupyter Notebook. The best way to do that is really to just explore it yourself, look at some, do some hands-on tutorials and just use it. So I'm just going to do a little bit of a demo of what's possible with Jupyter so you have an idea of what that thing is. And then we're going to dive into the data analysis part. So first of all, I'm going to show you how to load and inspect data using Pandas. I'm going to do a tiny bit of data cleaning. I'm going to do a tiny bit of data analysis, some data visualization, which I'm really excited about. And then I'm just going to wrap that up. I might not make it all the way through all the material, But as I said, this notebook is pretty self-contained. So if you want to just like start up the binder like after this workshop and go through the notebook, go through the tutorial itself, there's a lot of explanations and everything that should help you get through the exercises, and it should help you just complete the whole workshop. All right. Another thing I've done here is there's a couple of blocks that are blue that are marked as a DIY exercise, so there's no solution yet, and you're prompted to do the exercise yourself. So again, I'm going to leave this for the reader to do at your own pace. Okay, let's get started with the introduction. So first of all, what is Jupyter and what's like the whole Jupyter ecosystem? There's a lot of terms that are being thrown around, so I'm just going to do a lot of talking and give you some explanations. So first of all, what we start with, obviously we know Python is a programming language that we all know and love. IPython is an interactive Python shell. So if you go to your terminal and just type IPython, I can show you that right here. I'm actually going to show that live. If I just type IPython, oh, okay. Pandas, Jupyter. I need to be in my virtual environment, so let me clear this. It's a little bigger. So now if I run IPython, I have to be in the right virtual environment in my Python environment. I have a Python shell, and I can say a equals 1, and then I can print a. And this really allows me to just write Python code any way I want, and it will automatically print the output. So that's IPython. So let's switch back to all the other things. And then we have Jupyter. Jupyter is a Python library that provides a web-based UI on top of IPython. So what you've just seen where I just define a variable, I type the name of the variable, I get the output, it has cell numbers. That is basically a Jupyter Notebook in a terminal. So Jupyter Notebook just gives you a really nice web-based UI that you're going to see in a little bit more detail in a minute. And so Jupyter allows you to create those notebooks that I've already mentioned. A notebook is really just a sort of collection of different, code. It's got markdown. It's got a lot of, it has the output of all the code that you run. So it's a really nice way to do data exploration, data analysis, write some Python code and get the output right there, rather than, standard way of writing a Python script and a .py like text file, and then executing this in your terminal and kind of having those things separate. In Jupyter, in a notebook, you get these side by side, which is really cool. Okay, so that was Jupyter. You might have heard, you might have heard the term JupyterLab at some point. So JupyterLab really just is another layer of Jupyter Notebook. It provides some additional features on top of Jupyter. For example, JupyterLab will have a nice file browser on the left-hand side that shows you like all the files you have in a directory. So a lot of people just run JupyterLab locally instead of using Jupyter Notebook. To me, it doesn't really make a big difference. You still get the notebooks in the same way. And then finally, the word I've already mentioned is Binder. So Binder is a web-based hub for containers that contain your Python environment, and they render notebook based on a Git repository. So binders are super, super cool if you want to share notebooks in an interactive way and you don't know if the other person has the right Python setup. All you have to do is you go to Binder. That's a great. It is mybinder.org. So you go to mybinder.org and put in the URL of your GitHub repository that contains the notebook, and then it will install all the requirements, all the Python libraries that are necessary for that notebook. And then anyone can just go to that particular Binder page and launch a Jupyter Notebook in their browser without having to do anything locally. So binders are super great, which is why I recommend if you want to follow along with that workshop, just use the Binder link. Cool. Okay, so that was Jupyter, just to give you an idea of what I'm talking about. And again, we're going to be using this a lot in this workshop, so you'll figure out, you'll see what it is. Cool. So the next thing is Pandas, matplotlib, pyplot, seaborn. So lots of different words. So first of all, Pandas is a Python library for data manipulation and analysis. Pandas offers data structures and operations for manipulating numerical tables and time series. So Pandas is pretty much the go-to library in Python for modifying, manipulating, analyzing data. Matplotlib is a 2D plotting library in Python. And then pyplot is a collection of command-style functions in Matplotlib. They make Matplotlib work like MATLAB, if you're familiar with MATLAB. It's not very relevant to know, honestly. It's just sort of the underlying plotting library that is used and that you see always imported, and you're kind of like, oh, what am I doing with this? So just keep that in mind, that matplotlib is a plotting library. We often use seaborn. Seaborn is a kind of the go-to data visualization library in Python that's based on matplotlib. And I kind of think of it as a nicer version of pyplot. I'm just throwing this in the mix here because, it provides some nice convenient functions over pyplot, but you can also simply plot things using pyplot. And that's also built into Pandas, actually. So you can plot a Pandas data frame without using seaborn. But I'm kind of just giving you a little bit of an overview of a few of the different options that are available here. And finally, just to clarify this, you can totally use Pandas code, you can use seaborn, pyplot, et cetera, in a regular Python script. You don't need Jupyter Notebook. They're often sort of like thrown into the same pot, but they're kind of very different, like completely different things. Jupyter Notebook is just like an interactive Python environment, basically, or Python IDE, Python shell, whereas Pandas is an actual Python package that allows you to do operations on data. The two are very separate, but it is really, really nice to have your Pandas code and have your output of your results right next to it. So Pandas and Jupyter Notebook often just go together extremely well. So just keep that in mind. There's nothing stopping you from writing Pandas in a regular Python script and then executing that in, let's say, a data pipeline, for example. Okay, so that's a little bit of a background. I hope this clarifies some of the terminology here. Let's get started with a quick exercise in Jupyter. Okay, so Jupyter Notebooks are basically just interactive IPython terminal. Like I said, they're often mixed in with Markdown. So each input field that you see in Jupyter is called a cell. I'm actually going to just show you what it looks like when you create a new notebook. So you just go in here on your home page, create a new notebook using Python, and it's completely empty, and all you see is a cell with a prompt. Okay, so that's what's called a cell. I'm actually going to move this binder. Okay. Cells have two types that can be either code or Markdown. So they can be Python code or any kind of code, really. I'm going to show that in a second. Or Markdown, which means formatted text. You can really execute any kind of Python code. Like I said, it doesn't have to be Pandas. You could technically write all your Python code in a notebook and execute it there if you wanted to instead of Python scripts. Variables that you define in a notebook persist between cells. So even if I say, a equals 1 in one cell, and then I reference a 10 cells down, it will know that particular variable still. And very, very important, the notebook doesn't care about the order of cell, just the order of executing the cell. So if I define my variable A in a cell all the way at the bottom of my notebook and execute it here, I will be able to access it further up if I executed that cell first. So just keep that in mind. The order of the cells doesn't really matter if you execute all the cells manually. There is a method to run all the cells top to bottom, in which case the order matters. Again, I'm going to show this in a minute. Okay, so notebooks have two modes. The mode, and if you're ever used Vim, you might be familiar with that. It's I call it navigation mode or visual mode, and edit mode. So editing the cells, so first of all, you can navigate around the notebook. I just highlight a cell, and you can just like use your up and down keys. For example, you see various cells are highlighted. And then if you want to actually edit a cell, you can either click into it, or you can just press enter and you will get into edit mode. In order to get back out of edit mode, you can execute the cell, or you can just press enter, or sorry, not enter, the escape key. Okay. In order to execute the cell content, which, here I have a markdown cell. So you don't really execute a markdown cell. You just turn it from editing mode into markdown mode. You hit shift and enter. So shift and enter is really your probably most used shortcut in a Jupyter Notebook. You can also just hit run. Click the run button, but you're always faster using the keyboard usually. A few other shortcuts that are really helpful in command mode. You can press M to make a cell markdown, Y to make it code, so you can switch between the types. You can also use the menu here, and you can see code is Y, markdown is M, so you can do that. If you press A in command mode, so right now I'm in command mode. If I press A, it creates a new table above, a new cell above the cell that I have. And if I hit B, it creates a new cell below the cell that I've currently highlighted, okay? So there's a bunch of other keyboard shortcuts. They're listed out here. You won't see me using my keyboard, and you won't be following along, so I'm not going to go into too much detail here. But I would say familiarize yourself with keyboard shortcuts in Jupyter, because they'll just make your life a lot easier and faster. Okay, so let's look at this example of a code cell here. This is really just a hello, or prints hello world, okay? And it gives you the rounded value of 4.3 and imports of Python. So what it does here, as you can see, it prints. So I just executed it using shift and enter. It prints hello world, and then my output is 5 of rounding up the number 4.3. So super straightforward, and you can see the output here. All right. Very briefly, there is a concept called cell magic. I'm not going to go into too much detail. Cell magic basically is a wrapper function that applies to either a line or an entire cell in a notebook. And Jupyter comes with several built-in magic functions. You use the percentage sign or double percentage sign. So one of the most popular cell magics in Jupyter is the time function. So all you want to do is you use %time in front of the statement you want to time. So time just gives you the time of the execution time of this particular statement. You can also, if you're familiar with using that on a command line, that's pretty much the same thing, where you time the execution of a statement. So either you use the %time keyword magic in front of the statement that you want to time, which looks like this, and then it gives you, the CPU time, it gives you the time output. Or you can use percentage time, which applies that cell magic to the entire cell, has the exact same output. So just keep that in mind. Cell magic is a thing. One cell magic that's also very popular for working with data is the SQL cell magic. So you can actually execute SQL statements within a Jupyter Notebook, which is really cool because it gives you access to SQL, where otherwise you'd only just be using Python. So just keep in mind cell magic, %, or % keyword is a thing. Okay, there's a little DIY exercise just to navigate, create new cells, etc., etc. So you can do that on your own later. Okay, so that was the overview over Jupyter already. I hope it's given you a little bit of an idea of what to do. Again, there's keyboard shortcuts, but you can also just access anything using these menu functions. The most important thing is really the run function, because that executes the cell, and knowing what your cell type is, whether it's code or markdown. So here, clearly you have code, right? You have Python code, and all the text I have in between is markdown. So just keep that in mind. Okay, any questions so far? In case anyone has questions about Jupyter, I can take a quick break and answer them. Otherwise, I'll move on. Awesome. Okay, I don't see any questions, so I'll just move on. All right, let's get to the data part. So let's dive into Pandas. So first of all, the most important thing is you have to have data to work with, right? And what you do is you load the data from wherever it is located. So you can load data from a CSV file, you can load it from a database, you can load it from a dictionary object. So there's a lot of different ways to get your data. In this example, I'm just loading data from a CSV file. So I'm starting with a little bit of setup, a little bit of an import statement where I'm importing Pandas. I'm giving it the name PD. That's pretty standard, but obviously could give it any name or just refer to it as Pandas. I'm importing pyplot as PLT, and I'm also importing seaborn. These I'm going to use later on for my visualization. I'm using, as you can see now, a cell magic for matplotlib that says show all the charts inline instead of in a pop-up. And I'm also just using setting some parameters on pyplot that mean the figure size. So any of my visualization outputs is just a little bigger. These are totally not necessary in order to use stuff. This is just sort of my standard setup to make the output nice. Great. Okay, so I've used the word data frame a couple of times. So the question is, what is a data frame? A data frame is a two-dimensional labeled data structure with columns that might actually have potentially different data types. Think of it as like a table. Like a data frame is very, very close to a table, like in a spreadsheet or in a relation base. It is the most commonly used Pandas object, and Pandas actually borrows the concept of data frame directly from the programming language R. So for all the folks who are used to using R, Pandas data frames are basically modeled on that and do a lot of the same things and have a lot of the same behaviors. Like I said, there's lots of different ways to read data into the data frame. In this particular example, I'm going to read some data in from a CSV file that I have prepared. In this particular example, because I used to work with healthcare treatment data, I am using an example from oncology, so from cancer treatment data, where you can see a list of patients, what kind of drug, what kind of treatment they got, what the dosage was of that drug, and when they started the treatment. You don't really need to be super familiar with it. Just think of like they're getting medication and there's a start date for when they start on that medication. All right. Now for our first actual Pandas statement. So our first actual execution of a Pandas statement. So very, very simple. I'm using Pandas. I'm accessing Pandas. I'm using the read CSV function. I'm passing in the name of the CSV file that I want to load, and I'm assigning all this to a data frame. So I'm going to execute the cell, and as you can see, there is no output because Jupyter, and the same with IPython, doesn't show any output if I'm assigning a variable to something. So in order to see the value of that variable, the tx data frame that I've just created, I can just enter the name of that variable and execute that cell, and Jupyter will actually very nicely print a formatted table that actually looks really, really good for this particular variable. So as you can see, my data frame has 4 named columns: patient ID, treatment start, drug, and dosage. Or we have patient IDs that look like PT1, PT2, etc. Treatment start is a date. The drug is oncology, the cancer treatment drug, either cisplatin or nivolumab, and we have the dosage, which is just a numeric value. Okay, so that's our data. That's the CSV file we just loaded, and it just looks like that. You will see there is a column with some numbers on the left. I'm going to talk about that in more detail later on. That's called the index. Right now, don't worry about it. We'll go into this in a lot more detail because it's pretty important. Okay. So now that you have your data frame as the TX variable, let's play around with it a little bit and actually look at the data, right? If you're doing data analysis, one of the first things you always want to do is exploratory data analysis. So you just familiarize with yourself with the data. What does it look like? What columns do we have? What data types do they have? Do we see anything interesting in there? So all I do is I'm using a bunch of built-in functions on the data frame that I access just using a regular function notation in Python. So it's dot function name parentheses. Okay. So the first one, that's, one way to look at a data frame. If you load the table and you don't know what's in it, and you don't know what it looks like, how many columns, how many rows, you can use the .info function, which tells you that TX is a data frame. It has 24 entries. It has 4 columns. Here's the name of the columns, and here's the data type. So this is, and it even tells you how much memory it uses. And in this case, we only have 24 rows, so it's a really small data frame. Okay, so this is a nice way to look at, to kind of see like, oh, what does my data frame do, right? The next one that I use a lot is tx.head. So head gives you the first, by default, the first 5 rows of a table, just to give like a little snippet, because a lot of times your data frames can be very long. You have a lot of rows, and sometimes you want to just get like a little snippet at the top. So if you say head, it defaults to the top 5 rows. One thing you all can also do is head, let's do 2, and it just gives you the top 2. So head is a pretty straightforward way to just get a little snippet of your data. Like I said, head gives you the top few rows. If you want just like a random sort of sample of your rows, just because you might think the rows are ordered, there might be some bias and, whatever it looks like, and you just want a completely random sample, you can use the sample function, and it actually gives you a random sample. So now you see the patient IDs are kind of a little more all over the place. Okay, and finally, you can use the describe function. So describe gives you some basic statistics for numeric columns. So if you have any numeric values, it will give you the min, max, mean, etc. In this particular case, we only have one numeric column that's dosage, right? Everything else is sort of strings or dates. So I use tx.describe, and it just gives me the basic statistic for dosage. So it tells me how many values do I have, what's the mean, standard deviation, min, max, and percentiles, quartiles. Cool. So that's like some ways to look at a data frame using the function notations. There's other options to look at some more stuff. So I'm going to go in a little more detail. Leng is usually what you can use on strings or arrays, for example, in Python. You can also apply the leng function to a data frame. So if you do that, it will give you the number of rows in the data frame. In this case, again, we already know it's 24, right? You can also use a property. So just be aware that this is not a function. It doesn't have the parentheses, but it just has the name of the property. And your data frame has a property called shape, which gives you the number of, and now you're probably familiar with the shape of this data frame. It has 24 rows, 4 columns. So shape gives you 24 rows, 4 columns. It tells you how many rows and columns you have in your data frame. One other option is the dtypes property. Again, not a function, and I always forget that it's a property and not a function. So dtypes gives you all the columns and the data types. So dtypes, data types of each particular column. So keep in mind, Pandas doesn't say string. It says object for strings. Just keep that in mind. And then finally, we have a columns property too, which just gives you the list of the columns. So lots of different ways of doing the same thing. Find what is your favorite and then keep using that because there's lots of variations, right? And they all kind of give you the same information. Okay. Next up, there's, like I said, another DIY exercise that you can do on your own pace. All right. So now that we have a little bit of an overview of what our data frame looks like, we know 24 rows, 4 columns. We know the names of the columns, right? Let's assume we want to just print either a specific column and just look at that, or we want to select a specific row with a specific properties from our data frame. There's lots of different ways, again, of doing this. I am just going to show you sort of the ones that I use the most. Cool. So one option to return just a single column, if you want to just print one column in your data frame, you don't care about the others, is to use the this notation of the square brackets. So TX of patient ID. It's very similar if you're familiar with dictionaries in Python. It's the same notation. One thing just to point out in this tutorial, in this notebook, like I said, I have 24 rows in this data frame. If I print 24 rows every single time, it's going to be a lot of output. So I'm using the head property just to like reduce the output. If you're using this on your own, feel free to just delete the head function call and get the full data frame. So this is completely not necessary. I'm just using this for visual purposes here. Okay, so in this case, if I use this notation, I'm actually not, you can see the formatting is slightly different, right? Like if we scroll up to our pretty table that we had up here, when we do sample, when we do head, it's not that nicely formatted. That's because it's a different data type. So the data type, when we use this square bracket notation, it actually returns something called a series. So series is sort of like the cousin of a data frame. Data frames are two-dimensional objects. They have rows and columns. The columns might have different types. A series is a vector, so it's just a one-dimensional structure. It's very similar to a list. So keep in mind when you're doing operations on data frames, depending on what you do with it, you might return either a data frame or you might actually return a series. So just keep that in mind. You might be thinking you're working with a data frame, but you're actually returning a series. You can always check for the data type of this by using the type function that's built into Python, or just say type of the variable or type of the statement. And it tells you it's a series. Reshama asked if a series is different from NumPy array. So it is in Pandas, it is its own class, it's its own data type, but I believe it's just a wrapper for a NumPy array. But it is a different data type in Pandas that's called series. Cool. There is an alternative notation. So I've been using this square bracket notation. There is an alternative notation that's a dot notation to access the name, to access a column. So as you can see here, this does the exact same thing as using the square bracket notation to print that particular patient ID column. Personally, I prefer using the square bracket just for visibility, just for consistency. It makes it easier for me to sort of see, okay, I'm accessing a particular column here. This is the thing. And also because the syntax highlighting is kind of nicer. As you can see, there's no different color here. So totally up to you which one you prefer. I prefer the square brackets. I find it more consistent. Okay. So right now we've only printed one column as a series. Another option is to print multiple columns. So if I only want to print, let's say, patient ID and dosage, for example, I can pass, instead of passing a single string into my square brackets, I can actually give it a list of columns. Okay, so note the double square brackets. That's also something that at least the first few times you're using Pandas, you will probably get wrong. That doesn't work. Like, you'd want to have the square brackets because you're passing in a list of columns, which is denoted by the square brackets. So when I print this, you can see, keep in mind remember what I just said about a series being a vector, a one-dimensional object, basically an array or a list. That doesn't work, obviously, if I print out, if I want 2 columns, that's not one-dimensional anymore. So this statement returns a data frame again. Okay, so we can just, so you believe me, this statement using the double square brackets, passing in a list of columns, returns a data frame object again. I hope, again, this is something that you play around with, and at some point it makes sense. It might be sort of slightly confusing, like single brackets, square brackets to begin with. Just keep that in mind. Like, the more you use it, the more it sort of makes sense to you. Okay, and finally, one more thing you can do is print, for example, so you can have on the series, you can have an additional set of functions that help you with some data exploration. So one thing you can do is use the unique function on here. Again, we're accessing this column that returns a series. We can use unique, which returns the array of unique values in the data frame, as you can see here. Okay, so this is another nice way to look at some stuff. All right. Again, DIY exercise left for later. So, so far I've showed you how to access columns in a data frame, right? I'm printing the column patient ID, I'm printing the column dosage, printing both of those columns, which is again, like really nice for formatting. If you want to show output that's really just like, I only want to see values in this column, I don't care about the rest of the table, that's really convenient. One other thing you might want to do is only show specific rows, right? So if you're coming from a SQL world, for example, you always use your where statements, right? You say select star from my data frame or from my table where patient ID is X, right? So you only print the record or the records where your patient ID has a specific value, because you want to look at this in detail and you want to filter your output down to just those relevant rows. So very, very common operation that you do. In Pandas, you use the loc, L-O-C function to do that on your data frame. So keep in mind the difference between previously we used TX square brackets to access a column. In order to access row, you use the location, the loc function on here. So use .loc. The argument to that, and this actually uses, so it's not quite a function, it uses square brackets, but bear with me. That's the best way for me to explain this. But it does use square brackets, not round brackets, is you're saying loc, and then you give it a Boolean statement. So a statement that can evaluate to true or false for every single row that, that you have in your data frame. So you say loc, give me the location at which this column in my data frame, so again, we have a series here, like this particular column in the data frame has the value PT20. So I'm looking for a row or rows where the patient ID is 20. This is not super intuitive, I have to admit. It's a little tough to swallow and understand at first, but basically just keep the syntax in mind. You say .loc, square brackets, and then you repeat the name of the data frame, okay? So you basically say where this column, and you learn how to access a particular column previously, where the value in this column is the thing that you're looking for. So if I execute this, it gives me, in this case, 2 rows, because PT20 actually has 2 entries in that data frame. Okay, there is a shorter location, shorter notation instead of using .loc. You can really just use, again, going back to the square brackets. I really prefer using .loc just to be more explicit. This gives you the same result, as you can see. I really recommend I recommend using this just consistently, because you know, just to be very, very explicit. I prefer being explicit in like what I'm actually trying to do. Okay, and the cool thing is, so right now we have text of patient ID is PT20. equal equal. You can also use Boolean conditions, so you can actually concatenate or put in more conditions. So in this case, we have the statement where patient ID is 20, and we're just using a single ampersand, not a double ampersand, but it's just a single ampersand here to do a Boolean and. And then we're also looking at where the value in the drug column is cisplatin. Okay, so using this ampersand to use a Boolean and you have, I'm using parentheses around each individual statement just to be very explicit. Oh, okay. So Reshama actually asked how I do an or. This is a great question. I do believe it is actually just the pipe. So right now, this is like not the most useful statement where patient ID is PT20 or the drug is cisplatin. So you get all the patient IDs. I can maybe do something like where patient ID is 20 or patient ID is, let's say, 3. And that gives me all the records where patient ID is either 20 or 3. So I'm getting all the records, my 2 that I had for PT20 and for 3. So use the pipe separator or operator for that. So pipe and ampersand. This one obviously won't give us anything because we have unique patient IDs. So no one can have a patient ID that's 20 and 3 at the same time because there's only one value in there. Okay. So this is honestly, if you take away one thing from this workshop, I think locating rows is a thing I do a ton. And for me, switching over from SQL, so I started with SQL before I switched to Pandas, that was the hardest thing for me to understand. Is like, how do I do my where statement? So this is your where statements if you're switching from SQL. Great. One very brief thing to show you, again, like just thinking back of SQL land where you can order by, like you can sort your output. There is a, you always want to sort things in ascending order, descending order, just because it's nicer to look at, really. You'll also need it for plotting at some point. But this is a really, simple way of sorting your output. You just use the function sort values. Again, I'm just using the head here. That's not necessary. And then you give sort value. So this is a function with round brackets around parentheses. You give it the column you want to sort by. So in this case, let's assume we want to just look at like what's the earliest and latest treatment date in our data set. So we sort by the treatment start column. Boom. Cool. So we sort by treatment start. You might notice something here, which is this is actually kind of not sorted correctly, right? 110, 114, and then 12 for anyone who doesn't do American dates. So this is January 10, January 14, and then January 2nd. So what's going on here with the treatment start column? I'll talk about that in a minute because that has to do with data type. So we'll do some data cleaning here. But just keep that in mind. This is how you sort your values. If you want to sort your values in descending order, so it defaults to ascending. In this case, we're doing a string sort. If you want to sort them by in descending order, you use the keyword ascending and you give it the value false. There's no descending keyword. It's ascending equals true or false, and you just have to remember that. So in this case, if I want to send a sorted descending, I'm saying ascending equals false, and I can start with the highest value. Okay. There's also, I can also sort by 2 columns. Again, I pass in a list. So at this point, maybe this starts making sense. I can always pass in either a single value, a single string, or I can pass in a list of column names. So in this case, I'm sorting by patient ID and treatment start, and this sorts by patient ID first, and then treatment starts if my patient has more than 1 treatment start. Okay, one thing to keep in mind, if we're doing a sorting, this only sorts the output. It only sorts the visual output in a notebook. It does not modify your data frame. If there's one other thing that you take away from this workshop, it's most of the things you do with your data frames, most of the functions you call in it won't actually modify data frame. It'll just show up differently in your output. It just modifies what you see in your output. It won't modify the actual data frame object. In order to modify your data frame object, you use a parameter called inplace. So if you use the inplace parameter, you actually modify the data frame. I'm going to show that. So just going back to our data frame that we just had, tx. As you can see, it is completely unsorted here, or sorted the same way as it was sorted before. It's not sorted by patient ID and then treatment start, right? You can see that here because PT1 only shows up once. If it's sorted by patient ID, it would show up multiple times. If I want to make this sorting permanent in tx, I can, again, just sort it by these two columns, and then I can use the parameter inplace equals true, which sorts it in place, which makes it permanent in that particular data frame. So as you can also see, if I use inplace.true equals true, it does not return any, it doesn't show any output because it actually modifies the variable. So in order to get output, I just show, again, tx or tx.head, and I get patient ID 1 at the top. Okay, I hope that makes sense. So keep in mind, anything you do to your data frame, other than adding columns, which you're going to see in a minute, doesn't really do anything unless you use inplace equals true. So Chandrasekhar just asked, after all the steps, if we don't use inplace and write data frame, exactly as you can see here, this is unsorted. But now, because I used inplace, it's sorted. So the changes aren't permanent. Another DIY exercise for you for sorting. And we are going into data cleaning. I am running a little behind. I think this workshop was originally supposed to be 90 minutes. So I hope, again, the notebook is there if you have to drop in the next 8 minutes. If you have to drop, go on the GitHub page and just do it at your own pace. I'm definitely going to try and cover a little bit more content here. Okay, so data cleaning. If you work with data, you've probably heard the term data cleaning a lot. Data cleaning just means you get some data, you want to work with it, and you kind of apply some transformations to it in order to make it actually usable in the way you want to use it. So in this particular case, you already noticed we had a little bit of a problem, namely with that treatment start column. I wanted to sort it by, if you go all the way to the top, I wanted to sort it by treatment start, and I ended up with 110, 114, so January 10, January 14, and then January 2nd. That's because it did a string sort, because the letter, the number 2, comes after the number 1 in a string alphabet. So that's just how it sorted it, but that kind of doesn't make sense, right? Because we want to sort it by dates. We know they're dates. So if we go to our data cleaning section, and look at the D types again, we've already covered that. You see treatment start is an object. And like I said, objects basically means string here. But we want this to be a date object, right? It's a date. We want this to say date or date time. So the easiest way to do this is to convert it to a date time. And this is done using a built-in function in Pandas, which is called toDatetime. So what we do here in this particular, in this cell is we say PD toDatetime, so call this datetime function on this particular column. If we only did this, if we only ran PD toDatetime tx treatment start, that would only, I can actually do that real quick. I can show you. This will give you nice output of a datetime series. Great. So it actually tells us this is datetime. Fantastic. But it doesn't actually do anything to our particular data frame. So in order to actually modify what we have in our data frame, what we do is we use this series conversion and apply it to a column. So we assign it to a column. And in this case, we're actually overriding the column called treatment start. So it's basically says, in this column called treatment start, take the value of this particular field in the treatment start column, convert it to a datetime, and write it back. So you're just reassigning it. So again, because I'm doing a variable assignment, there's no output. I think that's, hope that's clear by now. And then if we check the t types, we can see that our beautiful treatment start column now is a datetime. One of the things to keep in mind, here I wrote it back. I can totally give this some other name, and it would add an additional column called treatment start datetime, for example, if I wanted to do that. In this case, I'm just overriding it because I want this to be a permanent, permanent transformation. There's an alternative notation using, again, the dot notation instead of the square brackets, but I think by now you know I prefer square brackets for everything because it gives me nice syntax highlighting here. Okay. Actually, I might skip that particular part about copying data frames and just jump right to the data analysis. Okay, so one second. Sorry. I'm just like scrolling up, making sure I don't have anything. Okay, so now my data frame is in a really nice state. Let me just, for the sake of it, just print it one more time. So you have patient ID, treatment start, drug, and dosage. And let's assume we actually get started with data analysis and we want to find out what's going on at this particular clinic that treats patients. How many patients do they have? When do they start treatment? What kind of drugs do they get? What kind of drug dosage do they get? What's going on here? So I have 3 little exercises here to do a little bit of data analysis. So the first thing I want to look at is just how many unique patients does the practice actually treat? Like I've printed the different patient IDs. I could count it manually if I wanted to. But one option is to basically just say I'm using TX. In this case, I'm actually using the dot notation patient ID dot unique. So I'm just counting the unique values. And I'm also just printing the length of the data frame just as a comparison. So I have 24 records here, and I have 20 unique patients. This is really, honestly, testing for duplicates or duplicate-like IDs is always like the first thing to look at when you do data analysis to kind of get an idea. Is like, does every patient here only have 1 record? Do we have multiple records? What's going on here, right? So this is a really good way to just get an idea of, okay, we definitely have duplicate patient IDs. So patients have more than one record in this data set. All right. Second question. Okay, so now we know roughly what patients we have. What are the drugs? What are the medications that are given at the practice? And how many patients actually receive those drugs? So one cool function in Pandas that's also, again, built in is called a group by. Again, think back if you do SQL, there is a group by. You group by a column or by multiple columns, and it allows you to do certain statistics on that particular column. So if I do a group by, it really doesn't do much. It just gives me a data frame group by object. So a group by on its own is not particularly useful. You always want to do some other operation on that grouped object. In this case, you can do counts, you can sums, you can do means, so any kind of like really simple aggregate function on those group values. So let's assume I want to just see which drugs are given at the clinic, and you've already seen one called cisplatin, one called nivolumab, and how many, how often these are actually given for those patients. So I'm doing tx.groupby, I group by drug, and then I count how many records I have for each of those groups, for each of those 2 drugs that I have. So in this case, I have a column called drug. I have cisplatin and nivolumab. Those are the 2 drugs. And I have 16 records for cisplatin and 8 for nivolumab. Keep in mind, I'm saying records here. I'm not saying patients, I'm saying records. The reason for that is because think back to what we just found out. We know some patients actually have more than 1 record in here. So there are some duplicates. So that means some patients might also have more than 1 record with that same drug, right? So let's actually see how many unique patients we have per individual drug, or are there some patients that just have like multiple treatment starts for the same drug, which is totally possible. Not very common, but you know, it's totally possible to have multiple starts here. So what we do is, oh, sorry. I am doing a group by, and I'm skipping this cell, sorry. I'm doing a group by, grouping by drugs, and I'm looking at nunique, number of unique values in each row. Okay, so instead of doing a count, I'm doing a unique count. So if we go back to this, we actually see we have, in this case, the same number of patients, the same number of patient IDs for both of the drugs. However, as you can see, treatment starts have fewer unique values. So some patients start on the same day for this particular drug. And the dosage, which probably makes the most sense, is not totally unique. We only have 7 different dosages, and nivolumab is actually only given at 1 particular dosage. So that makes a lot of sense because you have standard dosages, right? And it's not super unique across them. So remember, the other one was 16 and 8 here because that counts records. This one counts unique values. Yeah, nunique is very helpful. Cool. All right, again, a little DIY exercise. We are at time, so I'm going to do like another 10 minutes maybe, I think, to get through most of the content here. Feel free to drop off, go to the GitHub page, go through this notebook by yourself. Lots of explanation here. Should be self-explanatory. I'm going to continue with indexing. So indexing in Dataframes is one of my favorite and most confusing topics. It took me a long time to like understand what's going on with indexing. So let's say we did a group by on this particular column. So again, we're grouping by drug. We're doing a count. One thing we can do on this is to actually print, like access just this particular column called patient ID. So we're only printing that out. And we're not dropping, but like removing the other columns from the output, because in this case, we only care about patient ID. So let me show you that. So we have the patient ID column, right, accessing like this. So this returns an actual data frame because we're using the list notation as an input here. And we have this column called drug. However, notice that this is bold now, and all the values here are bold, and it's sort of like at a different, like it's formatted differently, right? If you look back to our original data frame, all the way at the top, you can see patient ID, treatment start, drug dosage. These are all bold, and these just look like regular columns, and we have those bold numbers on the side. Now we have, let me scroll down again. Now we have the drug column bold for some reason. What happened? Reshma, I see your questions. I'm going to explain that in a minute. So what happened here? Why is drug bold? Drug got turned into an index. So if you use the group by function and group by a particular object, it becomes the index of this data frame. The index is a row identifier. If you look at it visually, it's the column all the way on the left that's printed in bold, but it's basically how you access your row. So if you think back to the very first time we loaded data frame, you saw all these integers on the side, just the numbers, right? So if you load a data frame, it will just automatically assign those integer indexes. And a lot of times you really don't care too much about the index. You can access a row by this index to just give it the number of the row that you want to access. Honestly, to me, that's not very common because I never know in which row a certain thing is in. If you have a index that actually has names or like specific values in there, like terms that you want to access, that makes a lot more sense. Most of the time, however, I have to be honest, I kind of throw away the index. The way you do that is by calling the reset index function, again, on all this output, on this particular data frame. So I'm going to show that, and then hopefully it becomes a little clearer what happened. Okay, so if you do reset index, what happens is it takes the index and it resets it to the default state of a data frame, which is the index is just a increasing integer. So now you have your index column, I guess you can call it your index of your data frame. That's just 0 and 1 again. And drug and patient ID are regular column names or just regular columns. This is mostly relevant when you're plotting something, for example, and you don't want something to be treated as an index, but you just want to plot two different two columns as like your X and Y, for example, or you want to plot a bar chart. Again, indexing is it's one of those things where you just have to use it a few times and a few times run into like reset index. It's kind of like in place equals true, where you modify something and it doesn't change your data frame and you're, oh, I need to use in place. Reset index is like a similar concept for me, at least, where it took me a while to say, oh, I need to reset the index because this is what I want my data frame to look like, because I want this column to actually be a real column and not the index. Okay. One thing to keep in mind. Reshama asked if TX is a new object or does it need to be assigned as a new object? So again, all the things I'm doing here, if I'm doing like a group by or whatever it is I'm doing, unless I'm using an in place equals true, which I don't think works on group by, nothing gets modified. So if I'm just doing tx.head, this is our good old data frame from 10 cells up with nothing changed really. Remember, we did sort it in place. That's the only modification we've done so far, and we've changed the data type. But other than that, it's there's no changes. So if you want to assign this to a new, if you want to make a have a new data frame that's with those values that looks exactly like that, you make a copy of it. I skipped that part. Do look it up in the notebook, because you can't just assign it to a new variable. So, but I'm skipping this for now. Okay, right. So as you can see, we now have our drug and our patient ID. We know we have 16 patients with, and again, I'm using count here because nunique and count in this case does the same thing. If you want to have actual uniqueness, use nunique here. And let's say we want to plot this, right? Because this is a cool case for data visualization. Obviously, with just 2 values, it's not super exciting. With like 5, 6, 7 values to actually see them next to each other, it probably gets a little more exciting. But let's plot our tiny little table here. Okay, so in this case, I am actually assigning everything I did here. tx.groupby by drug.count, only select the patient ID column, reset index. The entire output of this statement, I'm assigning to a new data frame. So my data frame counts now has this particular shape that we had here, right? This is the exact same statement. It looks like this with 2 columns, drug and patient ID. That's my counts data frame now. Okay, and then the next thing I'm doing is I'm plotting it. I actually want to make a nice chart with it. in order to do that, I'm using the seaborn library. Remember, I imported seaborn as SNS. I'm saying, okay, I want to do a bar plot. The data that I want to plot is my counts data frame. The x-axis is the drug. So I have nivolumab and cisplatin next to each other. And the y-axis is this patient ID column, which has the number of patients. Technically, I'd probably want to rename it from patient ID to something else. There's a rename statement too, which I'm not covering here, but just assume patient ID means the number of patient records we have. Another thing I can do, so in pyplot, I can set the title for this chart. I can set the Y label, so the Y-axis label. I can set the X-axis label, just like make sure everything is nicely labeled. As good data analysts and data scientists, we know we always have to label all our axes and our charts so there's no confusion. And then finally, we just say .show, so plot.show of this figure that we just created, the bar plot. And because we set plotted inline in 10 by 6, remember the statements I used all the way at the beginning, it will show up inline. So let's do that. All right. And this is our beautiful first data visualization. So again, x-axis, we have the two drugs, right? The drug column is the x-axis, cisplatin and nivolumab. We have our x-axis label called drug. We have our y-axis, which is the number of patient starts. That's the patient ID column. So we have the 16 and the 8 that we've seen plenty of times now. And we have the title, number of patient starts by drug. This is really my sort of default template for any plotting. Start with a bar chart usually, and then you can sort of take it from there depending on what type of data you have. All right. One last thing I'm going to cover in the last few minutes is basically just another way of looking at the data. So in this case, we want to look at changes to treatment over time. So remember, our data shows all the drug treatment starts by date. And we want to see, okay, let's say how many starts do we actually have per month for each particular drug? The reason for that is if you, and again, this is like sort of oncology specific, but you can think of this in like lots of other domains. You have a thing that's kind of the like typical default treatment. In this case, it's cisplatin. So cisplatin is sort of like the default treatment that patients have been getting for a specific type of cancer. And at some point, there's a new kid on the block. There's a new drug that comes out, and we want to see what the uptake is of that drug. So we kind of want to just plot the number of treatment starts for each drug for each month over time. So plot a time series and see if there's any trends. If like presumably one goes down, the other one goes up over time. So that's kind of what we want to see. Okay, in order to do that, like I said, I just want to look at it by month. I think that makes more sense to me than like having it for specific dates. So what I do first is I am creating a new column here that's called treatment start month. I'm using a slightly different way of changing a data type. This time it's as type datetime 64M, so that means month. But it's basically the same thing we did with the PD to datetime. Doing like datetime things in Python in general, Pandas in particular, is always a little hairy. Find the way that works best for you and then just use that that does the thing. I just have like a library of like, this is how you convert to the month. This is how you convert to the year. And then at some point you'll just memorize it. Okay, so in this case, like I said, we create a new column called treatment start month, which I have here. So this is a new column. So you can see treatment start, and then treatment start month is just the first of the month for every single record. So 2016, 0114 defaults to 0101, 06, so June 1st, April 1st, April 1st, et cetera, et cetera. So these are my month start dates, which allows me to plot it very nicely by month. Okay, so that's the first thing. The second thing I want to do is then I want to count the treatment starts by month. And if you've seen the previous group by that I've used, this is pretty much the same thing, really straightforward. So we're saying, again, a tx.groupby. So in this case, we're grouping by two things because we want to group by treatment start by month and by drug, right? We want to see for each drug, for each month, how many patients or how many treatment starts do we have. We're counting the number of records here, and we are only selecting the patient ID column from this particular output. So, and this is also just one thing to point out here. In Pandas, the main way to do anything really is you concatenate functions. You say .groupby, .count, .this, .that. So you'll end up with like a lot of functions just like concatenate and sequence. Cool. So we do this, execute the statement, assign it to a variable called drugs by month. That's our new data frame that contains the drugs by month output. So let's see what this looks like. Okay, so as you can see here, we have two columns with bold headers, and we now know this means we have two indexes because we grouped by two columns. So both of these columns became indexes. So we know that if we want to plot these, we want to reset the index for this one. I didn't do this here. I'm doing this further down. It doesn't really matter that much where you do the reset. Okay, so we have the month, right? This is January, February, March, April, et cetera, et cetera. And we can actually already see just from this table that January, February, we have only those two drugs, and then the new kid on the block comes in. So nivolumab starts here, and it gets higher. It goes from 1 and 1 to 2 and 4. Obviously, this is dummy data. Like real numbers would be higher if we're looking at an actual clinic. But this is sort of a trend that we can already see just from the table. But let's plot it and just look at this in a nice visualization. And that's the last example I'm showing for today. So again, I am creating a new variable called fig. Doesn't matter what you call it. I just stick with fig. Calling seaborn. This time we're doing a line plot because we're doing a time series. So doing things sort of like over time makes sense as a line. It could also be a bar plot again. And we are using this drugs by month data frame that I've used. We have to do the reset index. I could have done it up there. I just wanted to show you the double index here. We say X. So our X-axis is the treatment start month. We have a time series. So it's, the time or the date column is used for the X. For the Y, we have our patient ID, which again contains the number of treatment starts, the number of patient records that we have here. And then we use a third keyword here, which is hue. So hue means the shading or color of this particular line or bar or whatever it is. And in this case, we use drug as the hue, which means that for every different value of drug, we use a different color. If I didn't do that, it would just I don't think it would actually not work in this case because we do have different values here. So drug just allows us to split out, separate the different categories in this case that we want to distinguish visually. Again, we're setting a title, label for our y-axis, label for x-axis. This is familiar now. And then we're calling plot.show to show the figure. And before I show this result, I would like you all to just take 1 second to think of what do you think this looks like? What do you think the output looks like? So we're doing a line plot. The x-axis is treatment start by month. The y-axis is the number of treatment starts, so the patient ID column, and a hue is the drug. So just think about it real fast before I actually show it. Give it 1 second. Okay, so what I expect to see is a line plot with 2 lines, one for each drug, one for cisplatin, one for nivolumab. And just based on the numbers I've seen on the table, I expect nivolumab to start 3 months in and go up. And I expect cisplatin to start high up and then go down a little. So let's look at this, make sure this is true. Bam, that is exactly what happened. So we have our blue drug here, cisplatin, which starts at 4 treatment starts in January and then goes down. And we have nivolumab, which starts at 1 treatment start, continues with 1, and then goes up over time. Obviously, this is dummy data. This is not what the real treatment data looks like if we have hundreds and thousands of patients being treated. But this is kind of the a very oversimplified visual representation of this particular sort of change over time. So now you know how to plot a line, a time series. Okay. I am going to wrap up here. We're a little over time, just 20 minutes. There's a bunch more exercises in here. There are some optional exercises. So again, feel free to jump into the GitHub and go through that notebook by yourself. Lots of explanation, should be able to do that. Okay. So Reshama asked one question. She asked if I would say that this is a pivot table. Yes. So the drug table here, treatment start by month, and drug, this is basically a pivot table, right? So if you're using Excel and you have sort of the group by multiple things, that's a pivot table. Yeah. Cool. Any other questions that we have? Otherwise, I'm going to just give you a very brief wrap up. Any questions? Give you 2 more minutes. 2 more seconds. All right. Well, we have a thanks. Okay. So, oh, Tina has a question. Ask your question, Tina. Please post it in the chat. This is the Q&A, and Yola, this is, if you have questions, this is a Q&A. So before I wrap up.
Yeah, if you have any questions, just feel free to post them in the chat and, on the Q&A, and you can, think about it for the next 5 or so minutes or 10 minutes as Sam wraps up her presentation.
Oh, someone actually asked in the Q&A feature, so that's awesome. So in the Q&A feature, Tony asked, do you mind explaining what pivoting a table is, why, and how to do it? Oh, I think I kind of just said it. So pivoting a table basically means instead of having one single record in your table per fact, per thing that happens, right? Patient starts a treatment with a particular drug, a particular dosage at a particular date. Instead of having one record by that per that kind of fact, a pivot table basically just groups by certain columns usually that gives you some sort of summary, that allows you to derive some sort of summary statistics for this particular group. So in this case, the group here is January for cisplatin, and if we technically added nivolumab here as a 0, right? So that would be our full content. So pivot table is just really good way to see to do basic group bys with particular like descriptive aggregate statistics. I hope that's a decent enough explanation. In Excel, you can do a ton of board stuff with pivot tables, I think. This is sort of like the pivot table equivalent, and then it allows you to plot, again, by specific groups.
Also, Sam, I just want to add, the benefit to doing pivot tables in say, Python and Pandas is that it's easily replicable, right? Versus doing it manually in Excel every time someone has a new spreadsheet.
Yeah. There's a lot of clicking in Excel to get to a pivot table. And you have to know exactly which columns, like how you're actually doing the pivot table. This is easily reproducible because it's there in code. So if you get a new CSV file, say these are all from 2016. Let's say I just want to throw it at the CSV file from 2019. I basically run the exact same code if the data, like the file format is the same, if the column names are the same, etc. And it does the same. It does exactly the same analysis. So super convenient. Okay. John said the time series breakdown was quite informative. Thanks, John. Kathy asked, does Google Colab offer the same functionalities as the notebooks you use today? Yes, to the best of my knowledge, Google Colab is another option for Jupyter Notebooks. It's just Jupyter Notebooks, and you can do the same thing. I don't know how it works with actually installing any additional libraries. I think you should be able to do that too. Tina asked if it auto-completes when I'm typing column headers. That's a great question. Unfortunately, it does not, because I'm just, they're strings. So sadly, it does not do autocomplete. But, you try, like, let's say I'm trying to access TX of, I don't know, Doug, or even like this. It'll give me an error because this thing doesn't exist. Key error, right? So you have to make sure the spelling is correct. All right. Eniola asked, do I need to know data science to do artificial intelligence? That is a very broad question. This is a very long question to answer. Artificial intelligence is a huge field. There's so many different things you could be doing there. Image processing, image recognition, natural language processing, machine learning, knowledge representation, automated reasoning, formal logic. Artificial intelligence is a very, very large kind of on what field of data science you're actually, artificial intelligence you're actually looking at. I don't think I can confidently answer that question in a very concrete way. Okay. Someone else asked, Tina asked, what about tx.drug notation? Can that one tab complete? Great question. I also don't think so, but I never use it, so nope. No, it gives you tab complete on functions that are available in Python or in Pandas. It doesn't give you, so I don't know, you could just see like the describe, right? So it does that, but it doesn't know about the columns. Maybe there's a plugin. Oh, Tony actually says there's a autocomplete plugin. I'm sure there's a plugin for that. I just kind of do it the hard way, and like I said, use my good old square bracket notation for that. Any other questions, either in the chat or in the Q&A feature, before I do the wrap up? All right. Okay. So Tina asked if I can put a call to any function with a Boolean output when using lock to find rows. That's a great question. I think it depends on what function you're calling. I'm pretty sure if you, for example, where's my lock? Lordy Lord, where is my lock? Sorting, in place, sort values. There you go. There's my lock. It really depends on what function you're trying to call. I do believe the answer is yes. Like if you, regex search, for example. Yeah, there's a way to do regex search for this. I do not recall the syntax for that. Please do look that up. I do know something like this would probably be possible. So where I say, for example, where length, so length of TX patient ID is, let's say it's PT1, so it's 3. So all the single digit patient IDs. Let's see if that works. No, it doesn't. Okay, cannot be used without a Boolean index. Yeah, this is where it starts getting a little bit hairy, where I have to actually look things up, because this is where it gets a little bit complex. Sorry about that. But please do look up how you do regex search. I think that's, yeah, very, very commonly used concept, obviously, in addition to just doing like a string search. Oh, so Lauren asked, relive all the methods available in the library. This I have, it should be covered up here, actually. I hope so. No, I have, yeah.
Hey everyone, it looks like Sam is having some internet issues. So I will end this webinar now. I want to thank Sam so much for joining. And so maybe Sam is joining now. Yeah, she might be coming back. Okay. In the meantime, I will be, yeah, I think we lost you on the internet. So yeah, I'll let you.
Oh, again. Okay, sorry about that. I might just wrap up. I don't know how far you got. Sorry, Lauren. To your question, I think I don't know it off the top of my head. I'm completely blank on this right now, so it might make the most sense to just again, like, look it up real quick. But yes, it is possible to show all the methods that are available in the package. Okay, I don't see any other question. So I'm just going to do the wrap up before my internet disappears again. Sorry about that. We have 3 people on the Wi-Fi today. What I've showed you today, basic operation, Jupyter Notebooks, data frames and series and pandas, how to load data to a data frame, some basic data inspection. So you look at head, describe, dtypes, et cetera, Xing columns, Xing rows, sorting, grouping and aggregating, so using counts and uniques on group bys, indexing in data frames and reset index, keep that in mind. Also keep in mind inplace equals true, one of my favorite, and some very light plotting with seaborn using bar plots and line plots. Some of the stuff we didn't learn that you will get into pretty soon is joining and merging multiple data frames, filtering and deduplicating, more complex modifications of column values, so filling null values using what's called lambda functions, complex aggregates like sum, mean, etc. And as I mentioned, there's a renaming, which is super convenient, which we also didn't cover. Please do look this up. This is very biased. Like, this is kind of the stuff I use the most frequently. I'm sure the more you use it, the more you'll kind of either find things you do often in Excel, things you do in SQL a lot that you want to do in Pandas, and you can just look it up online. So this was really just, like I said, a little taster of sort of the tip of the iceberg. That's it from me. I am going to stop screen sharing. As I said, hop over to the GitHub to either just launch the binder to do the thing or try a local install. And yeah, thanks so much. Thanks for all the questions. Really appreciate it. Thanks for sticking around. I know we're very much over time. I miscalculated the workshop duration here. Great. Thanks, everyone. And thanks, Reshama. I can hear you.
Thanks, Sam, so much. The recording will be available within 24 hours. Thank you so much.
All right. Bye. Thanks, everyone. I'll stick around for a little bit, Reshama, just to say bye.
Okay, I'm trying to hit the stop. Oh, there we go. Stop recording.